Check it out. What's next Wednesday right before choir leaves? Trying to fit it in, or else it's going to be bad news for everybody. So, bad news bears. And the good news is, listen.
They have another receipt.
Thank you. Today we're finishing 8-4, starting 8-5. 8-5 is our final section. We might finish 8-5 on Monday. We have a review. Guys, it works perfectly. That's where we are. I'm not cramming anything in. If anything, I kind of gave us a little extra time on 8-4 because technically I had the test as Tuesday.
Yeah.
I had the test as Tuesday. I spread it out a day, so I moved it to Wednesday. So one more time. It was supposed to be on Tuesday. I eased it a little bit by putting it on Wednesday. Are we tracking?
If I don't know, something goes wrong and we gotta have the test on Thursday, can I just take it on Wednesday?
Yeah.
Because I'm going.
Yeah, but don't worry, it'll be on Wednesday. We're good.
Oh yeah, that's a pepper.
Okay, you aren't AP Gov, right?
No.
Okay. Pepper eyes probably for
No, but then your game's over.
Yeah.
They never did.
we never did one for winter, so
Just as much for guys. Pretty much. Except for this one.
Well, I think that's because that's our game. Yeah, so they have the games.
No, who's gonna love
That's the
that?
first
maybe that's it. It's like in general.
Where's the volleyball? Where's the volleyball? Where's the
Yeah,
volleyball? Where's the spring for hire? Where's the spring for hire?
You're so extra.
He's gotta get Stacy on board.
I know, man.
It's Brent's.
When goes to CIF.
Alright, on our marks.
Yes.
Get set.
Don't hand floppers, don't hand floppers.
You guys should have this written because our goal today is to learn and to get good at, for just 2 examples and we're done. 2 examples and we're done. How to get good at finding determinants using this. Still?
Oh, it is, never mind. I see the pause button now. Just kidding. It's just a little dark.
Using this formula. It should get nicer, but it's not. There it is. Using this formula. Okay, this is our goal using this formula. And why is this formula so good? Because 2x2 method, main minus opposite, only works for 2x2. 3x3 shortcut, main minus opposite. There should have been in parentheses on the opposite. Only works for 3x3s. This works for anybody, 2x2 or above. Okay? So, we're going to practice on a 3x3, even though there's another way of doing it. We did it real fast yesterday, got it to work. But let's check it again today and see if we can still get it to work. Why did I have you write it 3 times? Yep. There are 3 elements across, 3 elements down, so however you cut it, you have to think about this 3 times. So, we're going to first of all do row 2. Oh my goodness, homework might ask us to solve it 2 different ways once or twice. Yes, it might. And here's the reason why. Ready? Let's just do row 2. Who's row 2? This guy. How do I use that guy? Ready? Circle the 6, cross, cross. What did I just do? Get ready to make my minor. Okay. Circle the first element in row 2. Cross out the column and the row associated. Cross out the column and the row associated. I rewrite what's left. Here's how I find the determinant of A. I take the 6. I rewrite the remaining numbers. 4, 2, -7, -8. I take the 6, the circle, I rewrite what's left, what's not crossed out. 4, 2, -7, -8. Hold on, pause. Before I can keep going, what sign should I assign to the 6?
Negative.
Because remember, we think positive, negative, positive, have to alternate. We always start with this positive upper left-hand corner. So when we think about row 2, we're going to assign the signs negative to the 6, positive to the 3, negative to the 1. So a negative goes in front of the 6, plus the 3. Oh, wait a minute. Hold on. We got to go circle the 3. Cross out the corresponding row and column. Who's left? -3, 2, 4, -8. Good? piece to go. You only have to use one full row and or one full, sorry, not and, or one full column. That's all. The last number is a 1. I'm going to put a minus with that 1 because of the corresponding sign up above. I'm going to go ahead and cross. Who's left? -3, 4, 4, -7. Are we done? No, but we're awful stinking close. Any questions about what I've written down? This is what to put in front of the value. So 6 was what was being circled, and negative needs to go in front because of the position of the 6 in the matrix. The 3 is his own deal. A positive or a plus is going to go in front because of his position, and then the 1, a negative needs to go in front of him because of his position. So you would have a minus on the outside and a negative on the inside. So it would end up being a positive eventually. Yep, every single one. You just have to find the position of the elements and correspond them. That makes sense. Okay, how do we finish it, cool kids? Someone explain. How do we keep going?
You apply.
You apply. What do you mean?
The 6.
What are we supposed to do with these guys?
You multiply them by the
Scalar.
Can we just do mean minus opposite?
Yeah.
Aren't they little 2 by 2?
Oh, yeah.
Mean minus opposite, mean minus opposite, mean minus opposite, like we did in section 8.3, right? Just gotta keep on doing it. So -6 times, mean is -32 minus -14. -32 plus 14. Doesn't that end up being 18? Plus 3 times 24 minus 8. That's 16, I believe. Double check me. Minus 1 times 21 minus 16, which ends up being 7. Hold on, you guys double check. You guys get what I'm doing, right? -32 plus 14. 21 minus, oh no.
AD minus PC.
We got there. Now is it better? 21 minus 16 is fine. -32 plus 14. Man, it's a rough one. Yeah, it'll end up being a positive right now though, huh? -32 plus 14. Yeah, -18 times -6. Thanks, Ellen. Everything else good? Yep. Just mean minus opposite. So, 6 times 18. Let's see if we can improve our mental math. 108, right? Plus 3 times 16. 48, yeah? Don't just say sure, but is it good? Okay. 48 minus 5 is 43. 43 and 108 ends up being 140, 51. How do we double check? Calculator, that's no fun. What's the other way they told us to solve it?
By column 3.
By column 3. I have told you that you can solve it using one row or one column, right? Well, let's prove that. How do we prove it? We use a row and we use a column and say, hey, do the answers match? So ready? Letter B. Let's use column 3 instead. What does that mean? Well, we're going to have to choose different signs, right? I already have green. Blue. We're going to choose these guys. Plus, minus, plus to go with 4, -7, -8. Now you guys could rewrite your matrices. Oh, column 3. Let's do row 3. It's a rough day. There we go. There we go. Still plus, minus, plus though, thankfully. And we have 2, 1, and -8. You want to rewrite your matrices 3 times just to prove a point you can. But ultimately our goal is to be able to do it without having to write them 3 times every time, right? I'm going to go ahead and start setting up. That blue too light. I'll keep going with red. Determinant of A is equal to. I'm going to have 2 with a positive. I'm going to have 1 with a negative. And I'm going to have -8, check it with a positive. Yeah, I'm moving a little bit to give myself a little bit more.
So it stays -8.
Yeah. So the positive doesn't mean it necessarily ends up being positive. It just means outside the entry, -8, there's a plus. Does that make sense? So positive up above really means keep it the same, and negative really means flip it. So if I go to that 2 and if I cross, I think I end up with 6. Yeah. Go to the 1, cross, I end up with -8, cross, I end up with -42 minus 12, -54. Minus 1 times 21 minus 16, that's going to be 5 again. And then plus a -8, that's just going to be minus 8 times -9 minus 16. No, minus 24. -9 minus 24 is going to be -30. Yeah, right? I don't know why that was 34. -9 minus 24, -34. At which point, hopefully, we end up with -108 minus 5 plus 4264. 264 minus 115. 150. Hey, guess what would have happened if we had chosen any row, any column? Now we have one more example, then we're done with 8-4. One more. Now they say, hold on. They say, find the determinant using, I don't know why it's not using any row or column that appears to make the computations easiest. What? How is one row or one column going to make anything different?
The third column.
The 2 zeros we don't care about because we would have plus 0 minus 0. Right? So why did I only write it 2 times? Because we're only going to have to use the 6 and the 3. Because as soon as we go to the 0, 0, it'd be 0 times and it doesn't matter. Does that make sense, guys? The zeros would just cancel out that whole term, so why do work if it just ends up being 0? Now, hold on the signs. I'll have to write this every time, it's just so that you guys can see what I'm doing. We're choosing this guy, right? Let me give you a second. I'm going to freeze it so you guys can catch up. I'm going to keep going. So if you guys catch up with me, keep going. Believe me, on this problem, I want to make it as easy as possible. Guys, hold on, wait a minute, why am I doing all this craziness?
Oh, you.
Well, you guys had to do 6 with a 3 by 3, right? You had to do minus 3 with a 3 by 3. The dilemma is, don't we still have to find that 3 by 3's determinant? Yep. So I can't just do main minus opposite. You could do main minus opposite. Or you could just say, well, let's just keep going with the same process that we're doing. So why did I choose 1, 5, 1? Any ideas? I could have chosen anybody. Yeah, there's 2 1s, right? Makes the mental math a little bit easier. So I had to think of the signs one more time. I have a 6 on the very, very outside. Oh, the second from this guy. Does that make sense? So I haven't finished everything yet, have I? But I still have to do the 3? Just so that we don't forget about the minus and then put a minus in front of the 3.
Will you use 1, 5, 1 again?
But I think it's the easiest, right?
Mm-hmm.
Be careful, the matrix is different, so you can't use the exact same 2 by 2s as you did up above. Okay, double check on my little baby matrices, they look alright? Cross. I'm gonna simplify how I write determinant, because it's taking too long to write. There we go. It's a lot of places to make mental math mistakes, right?
Yes.
Do main opposite, main minus 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 opposite. See, right? Main opposite, main opposite, main opposite. Of course. If you guys want, you could distribute in your 6 now. I don't know if that makes it easier or better. Does that make it easier?
No.
Whoa.
Okay. So that'd be -6 times 49 minus 42. Well, that's easy. That's 7. Then plus 30. 6 times 5 times 14 minus 18. Okay, it's -4. These numbers aren't too bad. Minus 6 times 14 minus 21. That would be 7 again. Oh, -7. Thanks. Ooh. 14 minus 21, -7. Then I have, okay, let's distribute our -3 to everybody. All the outside coefficients. -3 times -1 is plus 3 times 42 minus 14. 6 sevens minus 2 sevens would be 4 sevens, right? 28. That's a little bit less. Then I have -3 times 5 is -15 times 14 minus 6. That'd be 8. Plus 3. Hey, it fits on one line again. 14 minus 18 is -4. Whew. Wowzers. That's busting it out. By the way, that's the determinant thing. Equals. Now I have what? -5. Hey, that's nice. -84, right? Minus 8 15s. That would be 4 sets of 30. 120 again.
Oh, it's 6.
So I have -240. -240 plus 72.
Instead of keeping everything in bracket, you just apply the 6 to the 6 and the 6. There's 1, 5, 1, 2,
166? Double check, I did that fast. Negative 240.
Alright, 160.
Oh, struggle. You're close. Negative 240, and then we had 72. Yeah, it's 8. Sorry, I did a row reducing echelon form with fractions last class. My brain
It's okay.
We almost got it. They didn't mental math check me.
Good, that would actually be awesome.
It was actually one. It wasn't quite as long as that. But it was one of the directions said use a calculator, and I wanted to give practice into fraction one. I showed it to her. 168, right?
Now
Woo! Alright, let's try another row. Just kidding.
you see, you
Okay.
have such a great sense of humor.
Hey guys, can I show you one really easy one? Ready? What if I want you to find the matrix of this, or no, the determinant of this guy? Find the determinant of this guy. You ready? Here we go. Let's do.
Oh my. Seems impossible.
Woo! Alright, find its determinant. You guys can choose any row or any column.
That's it. It's 0. It's 0. Whoa.
Whoa! Woo! I did all of that in one little
Oh.
quiz.
It's just right for this one.
Genius.
Why? Wouldn't you cross and you would have this guy times, right? Times the determinant, because if you choose the rest of his row or column, they're all zeros, true? So you'd have 2 times the next one, but hey, to do that one, wouldn't you do that? And then zeros would be the rest, and then wouldn't you do that? And zeros would be the rest, and wouldn't you do that? And zeros would be the rest, and wouldn't you do that? And zeros would be the rest, and then...
So negative 20, negative 60, negative 120.
Go team. Okay, anyway, section 8.5. Ooh, homework help. Wait a minute, this is a baby. 2 by 2. Oh, no.
Okay,
How would you solve this baby 2 by 2? Luke, what was your question? Which best math?
green is so.
Don't get lost.
I know, right?
It's technically a homework help. Let's just do this one last one. I think that's the last one.
Oh no.
Oh no, what can we do, guys?
Let's go about this.
Make it into a matrix. No.
Main minus opposite.
Oh.
Yep. So, main, those two, minus negative 14, which would be plus 14. Not as bad as it looks, right? Doesn't the absolute value mean determinant? To find the determinant, don't we have to do AD minus BC? AKA main minus opposite? AKA main opposite? London. Alright, you guys ready for main 5?
Yeah, let's do it. You missed it. You missed
Alright, here we go.
Wait, I missed
Oh, listen. Alright, 2 more seconds on this page. Now you guys are ready. Focus. Issa, focus. You 3 boys in the front. Maybe that wasn't
10 seconds, I walk out.
Good. That was a good, nice 30 seconds. Thanks, Misty. What a good one.
Well, wherever you sit, it'll kind of like give you the next assignment. Ready, set, go!
Okay.
It's not gonna be funny. Yeah, I got it. You're not gonna be able to reach the size in the back.
So technically the bone's not supposed to be finished like until 8 weeks, which is why
I have to be so funny to get back up.
I had to do period 1 today because technology was really bad, so they called it.
Oh, yeah, so I walk half seconds straight.
You guys better have this written down. Oh my goodness, otherwise. There's fun stuff in 8.5. We can't get to the fun stuff today. No, I'm sure it is.
Okay, English definition of is this
It's called cryptography. That doesn't sound right.
sounds like
Cryptography, cryptogram, ciphers? What's a cipher? Is this a cipher?
no.
Hold on, wait. Use your English skills. Pause my extra. Cipher, decipher a code. Coding?
They're gonna write us messages because it'll be fun.
The bonus on the test is going to be a hidden message.
Ooh.
Just all written like
If you hit message, you have to figure out what it is. Applications of matrices and determinants. Now remember, one more time, determinants are important. I'll show you a couple applications. There are many more. But to show you all of them, I have to teach another class that I haven't taken in years. So,
Just kidding.
but here are a few. Here are a few. What you're writing right now is one application. It's called Kramer's rule. I'm going to do the name Kramer. Not from a TV show. It's too old for you guys. A few of you guys.
Please help out.
His hair though.
He's gonna destroy his back.
Luke, you are not writing. Did you finish them? It was Luke and Luca. It was both. Oh! I just said Luke and then I meant both.
What kind of words for the
Luca. I love it.
Just say Luca, but spell with K's instead.
Luca with K's.
Lucas?
that way somewhere.
Lucas.
Oh,
My name was supposed to be Lucas. I don't know.
I think it's funny. Like, our
Alright.
name is something different. No, my parents had money. Mine was supposed to be
That's my mom's name.
Kalani if I was a boy.
Long story short, to solve a system of equations, we could solve for x and solve for y's using baby determinants. So we have the original system. I'm going to zoom in for my poor kiddos in the back. Hold on. We have that system. Okay? That system could be rewritten as a matrix. Real quick.
Okay.
We can do A1, A2, B1, B2, C1, C2. Nasty matrix, but there it is. Okay? Now question. From that matrix, question. Look at the x variable. If you guys look at this, it looks kind of like AB minus BC, and it is. It is. It's the main minus opposite if you take the determinant of that matrix. But where on earth does that matrix come from? Well, here's the long story short of Kramer's rule. whatever variable you are solving for, in this case, the one we're looking at is x. You take where the x's are in the matrix and you replace them with the constants. On top of Cramer's rule, you replace where the x variables are, x coefficients are, you replace them with the constants. And then you keep the b's, or you keep the y coefficients where they are. Look at the y variable. The a's stay the same, but what changes for the y variable? Yeah, the b's change, and the b's become what? Mm-hmm. So you can think about it as, to solve for the y's, you take away the y's from up above, the b's, and you replace it with the c's. And to solve for the x's, you take away the x's, take away the a's, and replace it with c's. And then on the bottom, you just take the coefficient matrix, aka the a's and the b's. And then to solve, you just do a little baby main minus opposite on top over main minus opposite on bottom. We'll use it. This isn't a huge deal. You guys have seen so many different ways to solve a system. We're not going to really go into tons of detail on this one, but it's kind of nifty how it works. It's an application of determinants. Did I miss some of you? So to do an example, maybe I'll go ahead and say one time. Let's just solve this system. We'll just skip the next page. 4x minus 2y is 10. Alright, example. The directions are use Cramer's rule to solve 4x minus 2y is 10. And 3x minus 5y is 11. So, using Cramer's rule. Let's use these formulas, okay? X is going to equal the determinant of 4, negative 2, 3, negative 5 on bottom. And take out the x's, leave the y's, negative 2, negative 5, but put in the constants instead of the x's, 10 and 11. See what I did? Take out the 4 and 3, put in the 10 and 11 on top. Solve for y. Take out the y's instead. So leave the 4 and 3, take out the negative 2, negative 5, replace with 10 and 11. On bottom, just keep all the coefficients again. So 4, negative 2, 3, negative 5. How do we solve? So x is going to equal main minus opposite, negative 50 minus negative 22 is negative 50 plus 22, which will end up being negative 28 all over. Main minus opposite on bottom, negative 20 plus 6, negative 14. Y is going to equal main minus opposite, 44 minus 30, 14. Main minus opposite, negative 20 plus 6. So the final answers are 2, negative 1. That's the one thing. You guys could have done substitution, elimination, RRE-ing of the little 2x3 matrix. That works also. Sweet, now we can skip the next page. Couple more seconds. The next page just says, hey, Cramer's rule, let's use it. Here's an example, yada, yada, yada. And it's the same example, so we're okay. You guys kind of see how it applies? Kind of, sort of. So say on a test, next Wednesday, if I was to say something like using Cramer's rule, I just want to see the work. You could always double check with another method. I'd probably do what? Elimination, I guess. That was kind of simple. Alright, that's application number 1. Kramer's rule. Application number 2, area. Now hold on, you go ahead and cross off this page. It's the same example we just did. We just did it nice and short and sweet. Okay. Now wait, pause. Could we use Kramer's rule to solve something bigger?
Yeah.
But does that really seem time efficient? Because what would you have to find? Over and over. That would just be for x. And over. Determinants of what? 3 by 3, 6 times. You really want to, if there were zeros in there, I'd say let's go for it, right? If there were zeros in there, I'd say let's go for it. It's great practice on solving determinants of 3 by 3s. I'd probably be lazy and do main minus opposite, but you know what, for right now, let's just say, you know what, that seems a little over zealous. So, here we go. Application number 2. Oh, I apologize. Zealous isn't cool anymore. Extra.
Oh, Miss, you saved up on the turn.
As long as we don't use jelly, I'll be fine. It's a pet peeve.
Really?
Wait.
I can use jelly.
What is this peanut butter?
That makes it a little bit cuter, but just jelly. Good. Let's keep it that way.
Wow.
It's in a microwave oven. Oh, it's that right?
Just turn it off.
Yeah, like one of those old ones. Yeah. I love my
Look, seriously, what a good
grandma.
You'd be left with so hungry.
Whoa, guys, look what's going on. Area of a triangle with vertices. So wait, if we know the points of the vertices, we don't even have to worry about the crazy law of sines, law of cosines thing to do it? Why am I saying that? Well, to find the area of a triangle, if we only know the vertices, we'd either have to find, let's see, the base and the height, but we might not necessarily have a right angle, so we don't even know how we find the height, number 1 and number 2. But then number 3, if we wanted to use Heron's formula, Heron's formula, that's an oldie but a goodie. Remember the S minus A, S minus B, S minus C? We wouldn't even be able to use that until we found the distance between those two, and then those two, and then, those two also, right? Distance formula 3 times just to be able to plug it in like a million times over there.
Not worth it.
So instead of that, hey, let's just take the 3 vertices and put it in this matrix with 1s at the end. Literally, yeah. Take the 3 vertices, put 1s at the end, take the determinant, multiply by plus or minus 1/2, whichever plus or minus keeps the area or makes the area positive. If it's already a positive, sweet, keep it the same. If it's a negative, think of absolute value, make it a positive. So why is this cool? If we have the vertices, it takes away the need for finding distances and or using those nasty formulas with sine of theta or lots of geometry-ish stuff. So, example. What if you were given this picture? They say find the area. Well, I guess we could do a distance formula there, a distance formula there, a distance formula there, and then use Herons. No. What are we going to do instead? A is equal to 1/2. We'll deal with the plus or minus in a second. Just throw them in whatever order you want. Let's just do 1, 0, 1, right? 2, 2, 1. 4, 3, 1. Now all we have to do is find a determinant. Multiply by 1/2 and we got it. If it's a negative, we'll make it a positive. If it's a positive, we'll keep it the same. Just so we're on the same page, let's just use section 8.4 skills. We'll use row 1. Does that look good? Has a 0 in it, right? We're going to have a positive, negative, positive for our signs. We have a 1/2 in front. We're using the 1 with the positive with 2, 1, 3, 1. Minus 0 plus 1 with 2, 2, 4, 3. I think this is easier than 3 distance formulas and neurons.
Isn't it 2, 4, 4, 1? Oh.
Does that make sense? Let me check the other one though. Yeah, we're okay. There were a lot of 1s though. It's easy to get the wrong one. Then main minus opposite, so 1/2 times 1 times anything of itself. 2 minus 3, negative 1. Minus 0 goes away. Plus 6 minus 8, negative 2. Doesn't that end up giving us negative 3/2? What are we going to do with that negative 3/2? We're going to say area is never negative, so just keep the positive portion. Dun, 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 dun. That's all the plus or minus weirdness means. It just means whatever's there, just make sure he becomes or stays a positive. Make sure he's positive at the end. And that saves us 3 distance formulas and neurons. Great.
So even if it's negative, you just change it.
Yeah, if it's negative, just change it to positive. Does that make sense?
Yeah.
That was application number 2. So we had Kramer's number 1. We had area number 2. Now this one's a little bit crazy, but not too bad. Application number 3. How do you know if 3 points are collinear?
Good.
You guys start writing more applications, collinear points. Sorry. Start writing down more applications, collinear points. We're answering the question, how do we know if 3 or even 2 points are collinear? They're only going to be collinear if you try to find the area and the answer is 0. AKA, take the area formula and say, well, if I try to find area and it's 0, then forget it, there's no area. Wait, 3 points always make a triangle, huh? Not if they're on the same line. Answer the question, how do we know if 3 points are collinear? Well, determinants can help us with that also, because if we try to find the area, if you guys want, no stress, don't think about another formula, just think of the area formula, right? Just put the 1/2 in there, put the plus or minus, whatever's. If the area ends up being 0, if the determinant ends up being 0, it's an impossible triangle, and 3 points will only not make a triangle if they're on the same line. Okay, that begs the question. This sounds kind of like we're done. We've seen 3 applications of determinants, but wait a minute, wasn't I saying something about ciphers and cryptography and all that craziness? This is what we're going to see on Monday. You don't write it down. We're going to see, wait, what if we assign every letter of the alphabet a number? And then what if we start taking messages and translating them numerically and then putting them in matrices to make them really I will see you. I'll see you on Monday. We're making ciphers.
That's it.
It's like really weird. It's cool. Hey, can I have some more? There's not a lot left, so you have to shake it up a lot. It's always,
What was the grade on it? Do you remember?
31 out of 35.
Spritzing.
I have
Spritzing.
this really fancy perfume that I usually wear, but I have this just in case, like,